Greetings, Dr. Dan with Optimal Optics, here to answer some prism problems. Unit 6P, these relate to what we learned in Unit 6 about prisms. So problem 1 gives us the refracting angle of a prism whose index is 1.54, the refracting angle beta equals 1.5, and it asks for the angle of deviation of a ray that's sent through the prism. And it says to round the answer to the nearest hundredth. So it's a matter of simply plugging into the formula epsilon in degrees equals n minus 1 times beta. So epsilon equals 1.54 minus 1 times 1.5. We take care of what's inside the parentheses and get 0.54. Multiply that times 1.5, and we find that epsilon equals 0.81 degrees. Question 2 gives us the power of the prism and prism diopters and the index of 1.5, and again asks us to find the refracting angle. So epsilon is now 2 prism diopters, and the index is 1.5. So now the formula we need to plug into is epsilon being in prism diopters equals 1.745 times n minus 1 times beta. So 2 equals 1.745 times 1.5 minus 1 times our unknown beta. So we'll take care of what's inside the parentheses. Make it equal to 0.5. So we have 2 equals 0.8725 times beta. We get beta by itself by dividing both sides by 0.8725. And we find that beta equals 2.29 degrees. Problem 3, the faces of a 6 and a 10 prism diopter prism are against each other, and their base apex lines make an angle of 60 degrees. What is the power of the resultant prism, and what angle does its edge make with the edge of the stronger prism? So if you recall, in Unit 6, I said I would show you how to solve this kind of problem using vectors. So I've drawn a horizontal arrow, which corresponds to P1, or the 10 prism diopter prism, and a diagonal arrow, which corresponds to P2, or the 6 prism diopter prism. And I'm going to divide each prism into a horizontal component and a vertical component. The two prisms have a 60-degree angle between them. So P1, which is 10 prism diopters, is entirely in the horizontal direction. So P1 horizontal is 10 and P1 vertical is 0. P2, I drew a right triangle, as you can see, and so P2 horizontal is 6 times the cosine of 60, the adjacent side. And P2 vertical is 6 times the sine of 60, the opposite side. And now to get the horizontal and vertical components of the resultant prism, we add up the horizontal components of P1 and P2 first, which is 10 plus 3, which is 13 prism diopters. And then we add up the vertical components of P1 and P2, which is 0 plus 5.196, and then we get 5.196 prism diopters. Now, to get the actual power of the resultant prism, we'll work backwards. We're going to draw these two vectors, the horizontal and the vertical, that we just calculated, horizontal being 13 and vertical being 5.196. And the diagonal vector is the resultant of these two vectors, and we'll solve for it using the Pythagorean theorem. A squared plus b squared equals c squared. A and b are the legs of the right triangle, and c is the hypotenuse of this right triangle, which corresponds to the power of the resultant prism. So this side is also 5.196. So 5.196 squared plus 13 squared equals c squared. And we find that c squared equals 196. So we take the square root of both sides, and we find that c equals 14 prism diopters. Now, to figure out the angle between this resultant prism and the horizontal, which is angle theta, you can see that the tangent of theta is 5.196 divided by 13, opposite over adjacent, and we get an angle of 21.79 degrees. Now we'll solve the exact same problem, but this time we'll plug into the formulas that you were given in Unit 6, and we'll see if we come up with the same answer. So P1 is 10, P2 is 6, and gamma is 60. The power formula is the square root of P1 squared plus P2 squared plus 2P1 P2 cosine gamma. So we plug in. Cosine of 60 is 1/2. And we find that the power is 14 prism diopters, just as we found with the vectors. The formula for the angle, tan theta, is P2 sine gamma over P1 plus P2 cosine gamma. And again, we plug in. And we find that the tangent of theta is 0.3997, and theta equals 21.79 degrees as before. Problem 4, two thin prisms are crossed with their edges at an angle of 30 degrees. The first prism produces a deviation of 6 degrees, the second a deviation of 8 degrees. Find the deviation produced by the single prism, which is equivalent to the combination, and also the angle. So we'll solve this just plugging into the formula. If you'd like to try solving it with vectors, feel free to do that on your own. So P1 is 6 degrees, P2 is 8 degrees, gamma is 30. We'll plug into the square root of P1 squared plus P2 squared plus 2P1 P2 cosine gamma. So we get square root of 36 plus 64 plus 96 times the cosine of 30, which is 0.866. And we have P is the square root of 183.1, which equals actually 13.53 degrees if you wanted to go to the hundredths place. Okay, to solve for theta, we use the formula tan theta equals P2 sine gamma over P1 plus P2 cosine gamma. And we find that the tangent of theta equals 0.3094, and theta equals 17.19 degrees.